Arrays are the simplest data structures, and we use them to store a list of items, like a list of strings, numbers, objects, and literally anything. These items get stored sequentially in memory. For example, if we allocate an array of 5 integers, these integers get stored in memory like this. Let's say the address of the first item in memory is 100. As you probably know, integers in Java take 4 bytes of memory. So the second item would be stored at the memory location 104, the third item would be stored at the memory location 108, and so on. For this very reason, looking up items in an array by their index is super fast. We give our array an index, and it will figure out where exactly in memory it should access. Now, what do you think is the runtime complexity of this operation? It's O of 1. Because the calculation of the memory address is very simple, it doesn't involve any loops or complex logic. So if you need to store a list of items and access them by their index, arrays are the optimal data structures for you. Now let's look at the limitations or weaknesses of arrays. In Java and many other languages, arrays are static, which means when we allocate them, we should specify their size, and this size cannot change later on. So we need to know ahead of time how many items we want to store in an array. Now, what if we don't know? We have to make a guess. If our guess is too large, we'll waste memory because we'll have cells that are never filled. If our guess is too small, our array gets filled quickly. Then, to add another item, we'll have to resize the array, which means we should allocate a larger array and then copy all the items in the old array into the new array. This operation can be costly. Can you guess the runtime complexity of this operation? Pause the video and think about it for a second. Here's the answer. Let's say our array has 5 items. Now we want to add the 6th item. We have to allocate a new array and copy all these 5 items into that new array. So the runtime complexity of this operation is O of n, which means the cost of copying these items into the new array increases linearly and in direct proportion to the size of the array. Now let's talk about removing an item. Here we have a couple of different scenarios. If you want to remove the last item, that's pretty easy. We can quickly look it up by its index and clear the memory. So here we have O of 1, which is our best case scenario. But when doing big O analysis, we should think about the worst case scenario. What is the worst case scenario here? This is when we want to remove an item from the beginning of the array. We have to shift all the items on the right one step to the left to fill in the hole. The more items we have, the more this shifting operation is going to cost. So for the worst case scenario, deletion is an O of n operation. So, because arrays have a fixed size, in situations where we don't know ahead of time how many items we want to store in them, or when we need to add or remove a lot of items from them, they don't perform well. In those cases, we use linked lists, which we're going to talk about later in the course. Now let's see a quick demo of arrays in Java.